Alright, welcome back to your favorite Inorganic Tutor YouTube channel once again. Today is another episode and we are going to look at integration by parts. Alright, and under the integration by parts, I'm going to show you two approaches that you can use to work out the integration by parts. Now, you know that the integration by part was involved from the product rule of differentiation. Alright, if not the integration by parts, you cannot integrate two functions that are multiplied. All right, so we will begin with the formula approach, right? So let's look at how we can find the integral of this particular problem. The integral of e power x e power 3x dx. All right, so this, we are going to use the formula approach to find the integral of this particular function, right? So in doing this, we have to consider, in my previous video, I taught you how to choose your u. In this case, I'm going to show you another way to choose your u, right? So this, we are going to use the LIATE, right? Where L is logarithm, right? I is inverse, A is algebraic, right? And T is trigonometry, and then E is expression, right? So this is the order in which you can use to choose your U as well. So when you have log, inverse, algebraic, trigonometry, or expression, then you consider those functions. This is in order, right? So when you have log, you choose that particular function as your u, right? And when you have inverse, you choose that as your u as well, in that order, right? So let's look at this particular problem, all right? Right, so this here, we are going to choose our u to be x, right? So if u is equal to x, then we can say that the u is equal to the x, right? So once you are done choosing your u, then we can go ahead and choose the rest of the function as our div, right? So div will be equal to e power 3x dx, right? So this integrating both sides of this function, then means this takes off this. We have v equals the integral of an exponential function, right? Is going to be e power 3x all over 3 plus a constant of integration, but we don't really appreciate that constant at this point, right? So right here, we know our formula for the integration by parts, v du, right? Now we have our u, we have our v, we have our du, right? So let's put in those parameters, right? So we have our u to be x and our v to be e power 3x all over 3 minus integral of v, which is e power 3x on 3, and du is the x, right? So this, we can go here, we have x e power 3x all on 3 minus, right here we can see that we can factorize 1 on 3 out. Then we have 1 on 3, the integral of e power 3x dx, right? So this here, let's integrate the e power 3x, then we can get our final solution, right? So we have x e power 3x over 3 minus 1 on 3. The integral of e power 3x is e power 3x all on 3 plus a constant of integration, right? So this here, we're going to have e power 3x minus this, and this will be 1 on 9 e power 3x plus a constant of integration. But we can see that e power 3x over 3 is common to this both terms, right? So we can factor 1 on 3 e power 3x out. Then we have x minus 1 on 9 plus a constant of integration. So this becomes the final answer to this particular problem, right? Let's look at the next example. So example 2 is going to be the integral of 3x cos 2x dx, right? So this here, we all know how to choose the u, right? So right here, we can see clearly that our u is going to be 3x, right? So here, u equals x, 3x. So differentiating both sides, we are going to have du equals x 3 dx, right? So now we have our du, we have our u, right? So we can choose the rest of the function as our dv. So now dv will be equal to cos 2x dx. So here we integrate both sides to find the v. So integrating both sides, this takes off this, and we have v equals the integral of cos 2x, right? You know that the integral of cos is sine, right? So we have sine into 2x. Then this is we have to apply the chain rule. So when you apply the chain rule and you differentiate the inside, right, you are going to have 2. So use that to divide the whole thing, right? So this becomes the v. So now let's apply our formula, which is uv minus integral of v du, right? So we have everything now. So with this, you're going to have u, which is 3x, and our v is e sine into 2x all on 2 minus integral of the v, which is sine into 2x all on 2. The u here is 3 dx. So we have 3 dx. Now, let's move up. Right, so this right here, we have 3x sine into 2x all on 2 minus, we can see that we have 3 sine into 2x times 3 all on 2. So we can have 3 on 2 out, integral of sine into 2x dx, right? So we finally integrate this part, then we can generate our final solution. So we have 3x sine into 2x on 2 minus 3 on 2, then integral of sine, right, is negative cos, right? So we have negative cos 2x all on 2. plus a constant of integration. Right here, let's expand this. So we're going to have 3x sine into 2x on 2 minus, we have minus and minus, so it's going to be positive. So we have plus 3 on 4 cos 2x plus c. Right, so this here, we can decide to factorize 1 and 2 out, but let's leave it this way, right? So this becomes our final solution to this particular problem, right? So let's look at our next example. Our next example, so example number 3, right? Integral of x sine into 4x dx, right? So this here, we know how to identify our u already, right? So this here, we know that our u will be equal to x, right? So the u will be equal to the x. So we can say that our dividend now is equal to sine into 4x dx, right? So here, when you integrate both sides, then you have your v to be negative cos into 4x all on 4, right? Now you have all the parameters. So what you do is go to your formula right here. Good. So our u, which is x, and our v is negative. So let's bring the negative here. So we have cos into 4x all on 4 minus integral of the v, which is this, negative cos into 4x all on 4. Then the u is the x right here. Good. So this right here is going to be minus x cos into 4x all on 4. Then we have negative, negative, right? It's going to be positive. So we have plus 1 on 4 in here. So we factor that out. So we have 1 on 4, the integral of cos 4x dx, right? So we know that this is going to be negative x cos 4x on 4 plus 1 on 4 into the integral of cos 4x is going to be sine into 4x on 4 plus our constant of integration. And right here, we can see that 1 on 4, of course, is common. We can decide to factor it out, but it doesn't necessarily make any difference. So let's just leave it that way. So we have negative x cos into 4x all on 4 plus 1 on 16 sine into 4x plus c. Right, so this becomes our final solution to this particular problem as well. Let's look at the fourth problem on the right? So our fourth problem is going to be integral of minus 2x sine into 5x dx, right? So this here, we've already worked a couple of this, right? So we know that our u, of course, is negative 2x. So the u will be equal to negative 2 dx, right? So right here, everything here is going to be our dividend. So integrating both sides, we have our v equals negative cos into 5x all on 5 plus a constant. Of course, we don't need a constant at this point. So we have our formula right here. So let's put in the parameters. U to be negative 2x. Our v is negative cos 5x over 5. So of course, we are going to have positive, right? So you have all on 5 minus the v, the integral of the v, which is negative cos into 5x all on 5 times the u is negative 2 dx. So we have times negative 2 dx, right? So this is going to be 2x into 2s cos into 5x all on 5 minus integral of negative cos 5x times negative 2. So you are going to have positive 2, right? So we have positive 2 cos into 5x dx. But it's all divided by 5, right? So this, we're going to have 2x cos into 5x all on 5 minus, we bring the 2 over 5 out. So we have 2 on 5 integral of cos into 5x dx, right? So integrating this particular function, minus 2 into integral of cos 5x is going to be positive sine into 5x all on 5 plus a constant of integration. Of course, we can expand this to have all on 5 minus 2 sine into 5x all on 25 plus a constant of integration, right? And this, of course, will be the final solution to this particular problem, right? So this is our problem number 4. Let's look at problem number 5. All right. So problem number 5 is going to be integral of 1 minus 2x e power negative x dx, right? So this, we can see clearly that we are going to choose this expression to be the u, right? So our u right here is 1 minus 2x, right? So differentiating this, we are going to have du equals negative 2 du, negative 2 dx, right? So once we are done with this, that means the rest of this is going to be the dv. So dv will be equal to e power negative x dx. So integrating both sides of this, we have v equals integral of an exponential function. If it was just e power negative, just e power x, then it will remain like that. But this is e power negative x, so it's going to be e power negative x all over -1, because the exponential function is negative, right? So we have negative e power negative x, right? Now we have everything, so we just quote our formula minus v du, right? So this here, our u is this 1 minus 2x, then our v is negative, so let's bring the negative forward here, e power negative x minus integral of the v, which is negative e power negative x, times the u, which is negative 2 the x, right? So this right here, of course, is going to be negative into 1 minus 2x e power negative x, right? Minus integral of negative, negative, right? So it's going to be positive. So we have 2 e power negative x dx, right? So now we can integrate this. We can decide to bring the constant out, right? So when we do that, you're going to have right here minus 2 integral of e power negative x dx. So we have negative into 1 minus 2x e power negative x, integral of e power negative x, of course we know what is going to be, e power negative x over -1, right? Plus a constant of integration, right? So this is going to be negative into 1 minus 2x e power negative x, then negative, negative, right? So it's going to be plus 2 e power negative x plus a constant of integration, right? So that is it to this particular problem. Of course, this is our answer, right? Of course, you can decide to factorize the exponential function out, but you can leave it at this way too, right? So this is our fifth problem, right? Let's look at the sixth one, right? The sixth problem. So our sixth problem is going to be integral of s squared e power -3x dx, right? So I just want to take it to a little bit higher level, right? We are going to double application or repeated application, right? Because we have s squared here. This means that we are going to integrate by parts 2 times, right? Integrate by parts 2 times, right? So this here, you can see clearly that our u is s squared, right? So we are going to have u equals s squared. So this means that our du will be equal to 2x dx, right? So if that is true, then means the rest is going to be our dividend. So dividend will be equal to e power -3x dx. Good. So integrating both sides right here means that our v will be equal to e power -3x all on -3, right? So once we are done identifying these parameters, come down to our formula, uv minus integral v du. We have everything, so we put them inside our u, which is s squared. Our v is e power negative 3x all on negative 3, right? So you can bring the negative right here, minus integral of v, which is this, e power negative 3x all on 3, right? Then the du right here is 2x dx, 2x dx, right? So let's move up here. We have negative s squared e power negative 3x all on 3. Right here, we have negative here, we have negative here, so it's going to be positive. And we can decide to bring the constant out, right? So, okay, let's do this first, plus integral of 2x e power negative 3x all on 3 dx, right? So this means that so far as we are still having two functions multiplying, it means that we are going the second time, right? But we can bring the constant out, the 2/3 out, to make the work so easy for us. So doing that, we are going to have s squared e power negative 3x all on 3 plus 2 on 3 all into a big bracket integral of x e power negative 3x dx, right? So this, we are going to integrate this again using the same approach. Then we substitute, then we get our final work. So here we choose our u again to be x. So this means that our du will be equal to the x. So this is going to be our domain, right? So integrating both sides means that our v will be equal to e power negative 3x all on negative 3, right? So right here too, we are done doing everything, right? So what we do next is, let's quote this again. So we have negative s squared e power negative 3x all on 3 plus 2 on 3 into, you know that this right here means that we have integrated and we are going to use the formula, right? So we substitute this formula in place of it, right? So doing that means that we have uv minus integral of v du right here. Good. So once we are done with that, then we're going to have negative s squared all on 3 plus 2 on 3 into, now our u is x and our v is this, right? So we have x, already this is negative, so we negative of that minus integral of the v, right? Which is negative e power negative 3x on 3. Now our du is just the x. So we have the x, all in a big bracket. Don't forget that. Right, so we have negative s squared on 3. We've forgotten our e power negative 3x, right? So this we have right here plus 2 on 3 into negative x e power negative 3x all on 3 minus, right? Now, okay, we have negative negative, so we can say we have plus integral of e power. Of course, let's factor the constant out, right? So we have this right here, the x, right? So we're going to have negative s squared e power negative 3x on 3 plus 2 on 3 into this negative x e power negative 3x all on 3 plus 1 on 3. Now, integral of e power negative 3x is e power negative 3x all on negative 3, right? Plus, of course, you close the brackets plus a constant of integration, right? So let's expand this, right? So when we do that, means you are going to have negative s squared e power negative 3x on 3 plus this and this, right? You're going to have, of course, there is negative here, so you're going to have minus 2x e power negative 3x on 9, then 2 on 3 times 1 on 3 is going to be plus, okay, there is a negative here, right? So you're going to have negative 2 on 27, right? This is 3 times 3, which is 9. 9 times 3, 27, right? So we have, of course, power negative 3x plus c, right? So this, of course, we are down the line, but we can factor e power 3 out. So we have negative, when you factor e power negative 3x out, of course, you can factor 1 over 3 e power negative 3x out. So when we do that, then we are going to have 1 e power negative 3x all on 3 into, now we are going to have only negative s squared in here. So we have negative s squared, then we have negative 2x on 3 right? Then we have negative 2 on 9 plus a constant of integration, right? So this has finally been our solution to this particular problem, right? This is the steps it takes you to get to a solution when you are having application or repeated application, right? But the other method that I'll be showing you, this is going to be cheap for you, because in that instance, you just create a table and you just work your way out. So let's try that method under this repeated application, right? So note the solution down and let's apply that same approach and see how swift that would be. Right? So now we are applying the tabular method on this particular problem, right? So in the tabular method, we consider our u to be the function that we can differentiate to a constant, and the v to be the function that we can integrate, right? So here, we know clearly that our u will be s squared, and our v will be e power negative 3x, right? So just create a table for it. Create a table for it right here. Now, what you do here, just differentiate this function, right, to a constant. Whatever constant you know, right? You can differentiate to 0. You know, 0 multiplied by anything is 0. So even if you take it to 0, that is fine. All right, so this right here, when you differentiate this, you're going to have 2x. Differentiate it again, you have 2, right? You can decide to end it here or go down 0, right? Come here, integrate this. We will integrate e power negative 3x. You have e power negative 3x all on negative 3. Go again till you reach this length, right? So do this. You have negative 3x all on positive 9, right? Go again. You have e power negative 3x all on minus 27, right? So this you are integrating. You integrated the v and you differentiated the u. So the v you integrated e power negative 3x. First you had this, then yeah, okay, no, that is fine. No, there's that is it. So this right here, you are done with your differentiation and your integration, right? So this right here, you know what you're going to do. This is the crucial aspect. What you do right here is going to determine your solution, because you know that the formula is uv minus integral v du, right? So it means that the first term is positive, the second term is negative. It means that if there is a repeated application, then the next term is going to be positive in that order, right? So we apply the same knowledge here. So here, this is what you do. This goes to this. This is positive. This goes to this. This is negative. This goes to this. This is positive, right? So this is the order in which you follow. Don't forget how you go about it. This goes down, this goes down, this goes down. How you effect the signs will influence your solution, right? So this right here, we know that this times this is going to be negative s squared e power negative 3x all on 3, right? This times this is going to be negative 2x all on 9 e power negative 3x, right? This times this is going to be minus e power minus 2 e power negative 3x all on 27, right? So we can see, this is the crucial aspect. Don't forget your constant of integration, because when you do this way, sometimes you might forget your constant of integration, right? So this, don't forget your constant of integration. So this is our final answer. So you can see clearly that we have the same solution. So let's decide to factorize as we did here so that you can see clearly the solution, right? So when we do that, 1 on e power negative 3x all on 3 out, then we have negative s squared negative 2x on 3. Then we have negative 2 on 9 plus a constant of integration. And that um, actually tells us that the tabular approach and the formula approach must give you same solution, right? So we can conclude that this also produces the same solution. But be careful when you are working with the tabular approach. Your signs must be very, very careful about them. All right, so that is the sixth problem. Let's look at the seventh problem. All right, for this approach, don't worry, I'll take you through this tabular approach for you to have series of examples for you to appreciate that as well. Right, so let's look at the seventh problem. Actually, we're going to look at 10 problems. Then we are done with the formula approach. Right, so our seventh problem is going to be the integral of 16x cubed ln x dx. Right, so this is our seventh problem. Right, this right here, don't just jump into choosing your u very quick. Right, if you don't take care, you choose this as your u. Right, I know definitely you choose your u as this, but don't forget that the integral of ln x is not that easy, right? So we don't choose this as our u, we will rather choose this as our u, right? So when we do that, it means that our u will be equal to ln x, so that when we differentiate this, we can have 1 on x, right? So the u will be equal to 1 on x dx. So this means that the rest of the function, this and this, will be the dividend. So we have dividend to be equal to 16x cubed dx, right? So we have integrating both sides, we have 16x4 all on 4 right here. Now we have everything, right? So we just quote our formula, right? Good, the u, right? So we have our u to be this, and we have our v to be this. So we have u, which is ln x, right? So let's bring the v first, 16x4 all on 4, right? We can simplify this to be 4s4, right? So we have 4x4 times the u, which is ln x, minus integral of the v, which is 4x4. The u is 1 on x dx, right? So right here, you're going to have 4x4 ln x minus integral of this right here can cancel out, and then we have 4x3 dx, right? So let's factor the constant out. Then we're going to have 4x4 ln x minus 4 integral of x cubed dx, right? So we have 4x4 ln x minus 4x4 all on 4 plus a constant of integration. Right here we can see that we can do the necessary minus x4 plus a constant of integration. Right here, we can see that S4 is common to these two terms, right? So we can do this right here. We have 4x ln x minus 1 plus a constant of integration. And this will be our final solution to this particular problem. Don't forget, I've already told you that if you have ln multiplying an expression or whatever expression you have, don't choose the ln x as your div. You cannot integrate. Of course, you can integrate ln x, but you have to look for another function or another constant to make it a product function to integrate. Right, so let's look at the eighth problem. Of course, you're almost down the line. So our eighth problem is the integral of the work itself, the integral of ln x, right? So this is what we want to integrate. Now, how do you integrate this? When you look at this straightforward to integrate, you can't, unless you remember that when you have a, it means that you have 1a. This is what this means, right? Naturally, this is how it's supposed to be, but you don't write this as a senior mathematician or whatever you are, you know what you are doing. You don't write this, you rather write this. But in actual sense, this is how it is, right? Now, right here, we can use the same knowledge. You can say that we have 1 ln x dx, right? So if that knowledge is applicable, then we can say that our u is ln x. So the u will be equal to 1 on x dx. So then we can identify 1 dx as our div, right? So we have div equals 1 dx. So integrating both sides, right? Then this cancels this. We have v equals x, right? So this is how you go about this kind of questions, right? So now we have our formula right here. Our u and v is already notes. So you have x ln x minus the v, which is x, and the du is 1 on x dx, right? So this takes up this, and then we can say that we have x ln x minus integral of 1 dx, right? So the same knowledge again, this takes of this. So we have 1x, which is the same as x, plus your big constant of integration. Now this becomes our final solution. Of course, you can factor x out, right? So we have x out ln x minus 1 plus a constant of integration. And this becomes the final answer to the eighth problem. I hope you are enjoying the lesson, right? Don't forget to pause the video and try your hands out before you continue, right? The ninth problem, please do well to pause the video and try your hands before you continue, right? So we're going to the ninth problem, right? So the ninth problem is going to be so fantastic, trust me. So this is going to be our ninth problem, which is integral of x is going to be fantastic. X cos into half x dx. Nothing is new here. Please don't forget to pause the video and try your hands out on this particular problem, right? Right, I hope you are doing that. Let's go. So u should be equal to x, and we have du equals the x. So if this is true, then we can say that this becomes our domain. So we have domain equals cos into half x dx. So this is going to be integrating both sides. We have v equals integral of course we have sine into half x all on half, right? So of course, and this can be 2 sine into half x, right? So this is what we have for the parameters. So we can quote our formula, right? So our u, which is x, and our v is 2 sine into half. So let's bring the 2 forward. We have sine into half x minus integral of the v, 2 sine into half x du is the x, right? So that's, now we have this 2x sine into half x minus, let's bring the constant out. So we have 2 into sine into half x dx, right? So we have 2x sine into half x minus 2 into integral of sine, right? It's already negative cos, right? So we have negative cos into half sine, all right? Half x all on half, right? Plus a constant of integration, right? Let's factorize it. After that, we add our constant of integration. Now we have 2x sine into half x minus 2. Of course, we have negative, negative, so it's going to be plus 2. Into, this is going to be 2 cos into half x, plus a constant of integration. So we can expand this right there. We have 2x sine into half x plus 4 cos into half x plus c, right? So we can conclude here, right, and say that this is the final solution to our problem number 9. When you have the fractions in that way, if you don't take care, you get it wrong. So got to open your eyes, right? That's how it goes. So let's look at the final problem on the list, which is our problem number 10. All right, so problem number 10 is going to be integral of 3x minus 1. Then we have sine into 3x minus 1 dx. Don't forget to pause, solve, put your answer at the comment section. I'll come back to you. I'll give you 4 minutes. Do that. All right, go. Let's go. So we have u equals this expression right here, which is 3x minus 1, right? So we have our du equals 3 the x. So if we are done with that, that means that our dividend will be equal to the integral of sine into 3x minus 1 dx. So integrating both sides, this goes off. We have v equals integral of sine. Of course, we have negative cos into 3x minus 1 all on 3, right? Now, we are done with this. We are done with every parameters that we are needed, right? We are interested in. Let's go to our formula. So our formula now is uv minus v du. So our u is 3x minus 1 and our v is negative. So let's try to bring our negative forward, right? So we have negative of that, just cos into 3x minus 1, right? All on 3, right? Minus integral of the v, which is negative cos into 3x minus 1 all on 3. Then the du is 3 dx, right? So let's rewrite this and have negative 3x minus 1 cos into 3x minus 1 all on 3. Then we have negative is going to be plus integral of, we know that this cancels of this, and we are going to have cos into 3x minus 1 dx, right? So we have negative 3x minus 1 cos into 3x minus 1 all on 3 plus, you know that the integral of cos is going to be sine into 3x minus 1 on 3 plus a constant of integration, right? So we are done. So you can decide to factorize the 1 on 3 out so that you have the cos inside, the cos and the sine, right? So we can decide to do that. So when we do that, it means that we're going to have 1 on 3 into negative into 3x minus 1 cos into 3x minus 1, right? Plus sine into 3x minus 1 plus our constant of integration, right? So this becomes our final answer to our problem number 10. Ladies and gentlemen, thank you very much for watching this video. If you found this video interesting and it has solved your problem, don't forget to press on the notification bell, subscribe, comment, like, and share to friends and other places. Thank you very much. Bye-bye.